Are you being controversial again? Now remember what I told you last week. You've got to be careful what you say. Good call, Nathan. Right. Oh, it's light. Now, the next topic then. So what we were doing in the first half is called definite integrals. And the next one, indefinite integrals. And the next one's called definite integrals. So there's really, really very little difference between definite and indefinite. So little of a difference, I think we'll only spend, 15 minutes on this. So what exactly is a definite integral? So previously we just did indefinite integrals, which is like this, yes. And the only difference is, for definite integrals, you have these things which are called limits. So these are called limits. And all they mean is this. When you calculate the antiderivative, we'll call it fx with a capital, and we write ab here. It just means simply put b in, put a in, and minus. Yeah. So the answer is fb minus fa. Yeah. Great. I'll give you an example. And the advantage of this is that we don't have to worry about the c. Even if I put in the c, it doesn't matter. So we'll do an example of this. Can I scroll down? Not yet? Yeah. Scroll down. Come on, there's only like two things there. I need to scroll down. Okay, so let's have a look at an example. So let's say we have 0 to 1 of 2x dx. So we know what the antiderivative is here. What is it? X squared plus c. Now I don't actually need the c, because watch what will happen with the c. First I put in the 1, so I got 1 squared plus c. Then I put in the 0, and I minus. Yeah, 1 plus c minus c. So the answer is 1. So because the c is always cancelled, you're not required to put the c in the question. So you could have just said this, x squared 0, 1, which will equal 1 minus 0, which will equal 1. You don't need to put in the c. We'll do another example, and then I'll let you try one, and then we'll have another example. Can I scroll down?
Yeah. The next lesson hard?
It's not too bad. Okay. Scroll down. Yes? Right, let's try this one as an example. 2 to 4, 1 over x antiderivative. So you remember 1 over x is going to be log x. 2 to 4. This will be log 4 minus log 2. Now, often in the exam they ask for the exact answer, so we leave it as logs, but we can also simplify. What can I do here? Log 4 over 2, which is log 2. So log 2 is the answer here. Yeah. Okay, try this one. Can I scroll down a little bit here? Yeah. I want everyone to try this one. Minus 1 to 1 sine x minus x dx. We'll need the calculator. So try this one. Okay, what answer do we get here? 0, yeah. So, what's the antiderivative of sine x? Minus cos x, and then this will be minus a half x squared. 1 and minus 1. So you put in 1 minus cos 1 minus a half times 1 squared, and then we put in minus 1 minus cos of minus 1 minus a half minus 1 squared. So let's see what we get here. Minus cos 1 minus a half times 1 squared. So what do we get here?
Minus 1.0.
Minus 1.04. And I think this one is also minus 1.04, etc. So the total would be 0. Yeah. What mode's your calculator in?
Radian.
Why radians?
People.
Yeah. Yeah.
If it was degrees, it would be different answers.
Well, I don't think in this case it will still be 0, but it'll be certainly wrong for each of these. Yep. Okay. Can I scroll down? Yep.
What about C?
Hmm?
Did you get, I think we can answer this well, right?
Yeah, we don't even bother writing it in.
I mean, like, I know it's going to be 0, but like in the exam.
Don't. Yeah, this is fine. Don't bother with the C.
Why?
It's going to cancel always for these. Always.
Yeah, okay.
So no need to. Do you need to go now? Yeah.
Yeah.
Okay. I want everyone to try this one for a moment. No, I was right the first time. Minus 1 to 1. Hey, do this one. Problem, yeah. So you should see now in a minute, if you haven't seen already, that this one actually has a problem in it. This one will be log 1 1 minus 1, which would be log 1, which is fine, but the second part of the problem, log minus 1. So log 1 is 0, so the answer is minus log minus 1, and this is a huge problem. It's not defined on your calculator. So the point I'm making with this example is that some definite integrals are valid and some are not. Some of them you can calculate, and some of them here clearly you can't calculate. And there actually is a very easy way to tell from the beginning if you can calculate or not. Can I scroll down? Yeah. So we have two types. We have what's called a proper and then an improper. Or another way of saying it is a valid and then an invalid integration, where this one is okay and this one is not. So I'll show you how you can tell from the beginning with an example. So let's say I had something like my minus 1 to 1, what was it, 1 over x dx, and here the one I did earlier was 2 to 4, 1 over x dx. So this one worked fine, and this one, oh sorry, I wrote that the wrong way around. Yeah, let me change the numbers. Two to 4, and then minus 1 to 1. So this one worked fine earlier. I think we got an answer of log 2, wasn't it? And this one we had no answer. And I knew that from looking at the question. If you look at the limits, it's the limits that cause the problem. And the way you can tell is here, what value of x can you not use? Yeah, x, well, actually just 1 over x. You can't use x as 0. And likewise here, x can't be 0. So what you imagine is, you picture you start here, and if you go all the way to 4, do you cross any problem values? So you go from 2 to 4, everything is good here. But if you start at minus 1, and you cross to 1, you crossing over 0 on your way from minus 1 to 1. And we're not allowed to use 0. Question, yeah?
I think we use like absolute.
Huh? If we use which value? Even if I put in absolute value? True, you could get a value out if you use log absolute value, but it still doesn't change that we call it an invalid integration. And I can give you more examples with log. I know what you're saying, that some formula books will write it like this. Yeah, and some will just write it like this. But that doesn't change what I'm making. My point I'm making here is that we still call this one improper because we're crossing a value we're not allowed to use. Now, it can be improper and we can still get an answer, like what you're saying here, but it's still called improper or invalid. And just because we get an answer doesn't mean it's the right answer.
But is differential 1 over ln x or ln absolute x?
I don't know for this course if they put in the absolute or not, because it's going to be in the formula book. Yeah. Did I put the formula book on Moodle yet? Let me check. Yeah, I did. So let's just check what's in the formula book. Now, I haven't done absolute yet, actually, because that's in the second semester. I'll show you the formula book here, actually, since I have it open. So this is the formula book that you'll get for the exam. So you can see that. Let me see, where is integration? Integration is page 5. Yeah, it uses absolute. Now, I haven't done absolute yet, so that's why I'm treating it like log x. This is actually a semester 2 topic. So, I don't know, in the marking scheme for the exam, they usually drop the absolute in the marking scheme and just write log x. Yeah, so this is a point I didn't want to mention until semester 2. These are the formulas I gave you, aren't they? Yeah, I think everyone, yeah. In fact, I gave you one extra, which, oh no, there it is. Yeah.
That's 10.
Now, these ones are not until semester 2. 1, 2, 3, 4, 5. These 6 here are not semester 1 integrations, they're semester 2. So for semester 1, you'll need to use from this one to this one. Okay? Tan x. I think that's a semester. Where's the syllabus? I think it's semester 2. But anyways, even if it is semester 1, it doesn't matter because the formula is right there for it. You just look it up and put it in. Yeah. And then on the previous page, these are the derivatives. And again, some of them aren't until semester 2. Okay. What you were saying is that you can sometimes get an answer if it's improper. So let's have a look at a couple of more examples. What about this one here? Minus 1 to 1 over, oh yes, 1 over x squared dx. Is this proper or improper? No, improper.
Yeah, 0.
You're crossing a 0, so it's improper.
Good to limit if you put minus 3 to minus 2, it will become
Now with, minus 3 to minus 2 of the same thing, this will be proper, because you're not crossing the 0. So, my point is, it's valid to calculate this, but it's not valid to calculate this. Even though this might have an answer. Watch, when I integrate x minus 2, what do I get? X minus 1 over minus 1. Yes? If I put 1 in, I get minus 1, and then if I put minus 1 in, what do I get? I'll get minus 1 minus 1 is 1. Yeah, and then if I put minus 1 in here, minus 1, sorry, yeah, that's it. So I get here minus 2, isn't it? Minus 2? Yeah. Now, in fact, this, believe it or not, is the wrong answer. The correct answer is not minus 2. And in fact, we'll see why it cannot possibly be minus 2 in the next lesson. And part of the reason the answer is ridiculous... No, we did this, Oh my goodness, Nathan, I did this one at the start of the first class, and I said, a very common mistake students make is that they think this is log x squared. Oh, okay, you're suggesting if it's... Yeah, no, it's still... What I said earlier is still true, okay? Now, this here is not minus 2, and in fact, in the next class we'll see why minus 2 is a ridiculous answer. But part of the reason the answer is ridiculous is, if this here is always positive, which it is, yes, then in fact it turns out that the answer should always be positive as well. Something we'll see in the next class. So this is completely the wrong answer. I don't remember what the true answer is, but it's not a negative number for sure. This here, when we get the answer, it will be the right answer. This is a proper and this is an improper. Alright, let's just check one more as an example. What about this one? Proper or improper? It doesn't matter. No, it can be this way, and it doesn't matter if it is the other one. It is improper. No. Yeah, but you're not allowed to put negative values in x. X should be positive. So every single value from here to here is not allowed. So this is improper. So any answer we may get here may be the wrong answer. It's an improper integration. Yeah? Okay, one more since you got a bit confused there. What about this one? Proper or improper? What is it? This one is proper. Are there any values of x not allowed for ex? No. So no matter what numbers I put here, it'll be fine. And then finally we'll say sine x, proper or improper? Proper. Again, we can put any value into sine. So there's nothing forbidden here. We can start here and finish here without hitting a problem.
So,
Now, this is not, you're not going to be asked in the exam to identify if it's proper or improper. I'm doing this because in some questions you'll get an integration and it will be wrong to try and calculate it. But it's not going to happen in the exam because they're not going to give you a question where you can't get the answer. And they won't ask you, can you get the answer here or not? Okay, but for later, we might come across problems where we can't get the answer, and this is the reason why, because it'll be improper. So, we will just do, let's see, a couple of these.
last year proper, right?
The last two are proper, yeah. Let's see. I'll pick what type they'll have in the exam. So let me just write this down. We'll just do a couple from each. So like question 1, you could do A and B, and then question 2, you could do F and G, and then question 3, you could do A and, oh no, sorry, not question 3, I meant question 4. Question 4, you should be able to do C. So here's some questions to practice. You can just do these for 5 minutes and then we'll start the next lesson then.
When you put B into it, and it becomes 0. There's 2 minuses, there's a minus outside and there's a minus inside. Does that become a plus or is it 3 minus?
If there's a minus on the outside of the integration?
Yeah, and there's a minus on the inside.
Oh, you can make that a plus from the beginning if you want.
Oh, by giving minus 1 outside.
Yeah. That is probably the easiest thing to do. I have the sign wrong in the answer?
No, you,
Okay.
when you see,
Continue. Which one? I want to check.